Welcome you all to my YouTube channel. As you know, this channel is for ICSE Physics. Today, I am with you to discuss about heat. It is the part 2, and in my previous part, I have discussed about what is heat, temperature, what are the effects of heat, and also at the last of that video, I discussed what is expansion. More about that expansion we are going to discuss in this video. So to get more videos of physics, subscribe my channel, like my video and keep your comments in the comment box. So let us start today's topic, this thermal expansion. Thermal expansion, first thing to know what is that thermal expansion mean. Then will come further types of thermal expansion. Thermal expansion is the phenomenon or the process in which a body increases size by the absorption of heat. Means when we are giving the heat to any object, its size gradually increases. That is thermal expansion. Thermal or the thermo term used for heat, expansion means the size will increase. Thermal expansion of solid means when we are giving the heat to solid, its length can increase, area can increase, and volume can increase. Means this thermal expansion basically of three types: linear expansion for length, superficial expansion for area, cubical expansion for volume. First thing, let's discuss about the linear expansion. Linear expansion. Linear expansion means whenever any object having the length more and area of cross section of thickness less, in that case its length increase and area increase negligible. That is called linear expansion. By the absorption of heat, by the gain of heat, when a body's length increase, it is called linear expansion. And linear expansion depends upon some factor. Linear expansion, first thing, depends upon which type of material we are using. Because some material can expand very soon, some material can expand a very large amount, but some can expand very less. Means some need less amount of it to expand, some need more amount of it to expand. So depending upon the material of the body, it requires sometimes less heat and sometimes more heat. Means linear expansion depends on material of the body. Second thing, it depends in the original length. Means if you are using a small object which is having the length less, it is having number of particles less. So when it will absorb the energy, when it will gain the energy, its increase in length also very less. But when the length of the body is more, then it will gain the heat. Molecular movement will take place, and in that increase in length also more means more the original length, more the increase, less the original length, less decrease. That means linear expansion means how much the body will increase its length directly proportional to original length. And third thing is the directly proportional to increase in temperature. Means two objects having same length, same material, same thickness. If to first one we have given 100 degrees Celsius and second we have given 20 degrees Celsius, obviously the body which will gain more amount of heat or when the temperature is more, expand more, the body which will take less amount of heat, when the temperature is less, it will expand less. Means it is directly proportional to increase in temperature. More the temperature, more the expansion, less the temperature, less the expansion. Now because the linear expansion is depending upon material, depending upon the original length and increase in temperature. So what is the relationship between all these things? That to come to mathematical expression. Here we'll discuss about the mathematical expression of increase in length. First thing, we have to take original length. Let at 0 degrees Celsius, body is having the at 0 degrees Celsius body is having the length L0, and when this 0 degrees Celsius increase to T degrees Celsius means how much degree increase? T minus 0 increase in temperature equal to T minus 0 T, and length increased up to LT. Means at 0 degree Celsius the body was having the original length L0. By increasing the temperature from 0 to T degree Celsius, that length increased from L0 to LT. Means how much change in length, how much increase in length, how much the linear expansion, LT minus L0. So this LT minus L0 is increase in length, is the expansion, depends upon two factors, original length and change in temperature. So LT minus L0 is directly proportional to L0, which is original length. LT minus L0 directly proportional to T, change in temperature. Change in temperature. T here the final temperature. 0 is the initial temperature. So change equal to T minus 0, T degree Celsius. So when we'll combine these two, we'll get LT minus L0 directly proportional to L0 into T, and to come when we have to equalize both this side in a proportion, we are using a constant. Here a constant used, constant or proportionality. Here you can see LT minus L0 equal to alpha L0 T. Alpha is the constant used here. This constant is known as coefficient of linear expansion. Coefficient is a fixed value. This value is fixed for different material, for iron, aluminium, silver. If we take any other type of solid, in that we'll get coefficient of linear expansion constant. And when we'll take LT minus L0 equal to alpha L0 T, that means alpha equal to LT minus L0 by L0 T, means from this we can calculate how much the coefficient of linear expansion of a solid. If we'll come to the unit of coefficient of linear expansion, unit is per degree Celsius, means per Kelvin, or per Kelvin. Per Kelvin the SI unit. That means if it is given to us coefficient of linear expansion 0.32 per degree Celsius. That means with the rise in 1 degree Celsius, length will increase how much? 0.32. Means coefficient of linear expansion will, from coefficient of linear expansion we will able to know how much the length of a body will increase by 1 degree rise in the temperature. So next one, let to come to the superficial expansion. Superficial expansion and cubical expansion. Superficial expansion means whenever we are giving the heat to a two-dimensional object, that may be a square, rectangle, or any object having quadrilateral shape, triangular shape, or square shape. Whenever a body gains the heat and its area increases, the surface inside a body is called area. When the area of a body increases, it is called aerial expansion, A-E-R-I-A-L, aerial expansion or superficial expansion. This superficial expansion also depends upon material of the body. It is depending upon original area, and also it is depending upon increase in temperature, same like the length. And another one for volume is called cubical expansion. Means whenever heat is given to a three-dimensional object which is having length, breadth, and height, or it will take a sphere, it will take a cone, cylinder. In that case, when heat is given, total space occupied by that object will increase. That is called volume. So increase in volume of an object on heating is called cubical expansion. Cubical expansion also same, depends upon material of the body. Here if you look, directly proportional to its original volume. In case of length, original length. In case of area, original area. In case of volume, original volume. Means more the volume, more the increase, less the volume, less the increase. With directly proportional to temperature, more the temperature, more expansion, less the temperature, less the expansion. It's like linear expansion. For superficial expansion, cubical expansion, also will get mathematical expression. We got a linear expansion. LT minus L0 equal to alpha L0 T. For superficial expansion, we will get AT minus A0, change in area, AT minus A0, AT final area, A0 original area, AT minus A0 equal to beta A0 T. This one, a constant used here. Here you can see a constant beta. Alpha used for linear expansion. Beta is the coefficient of superficial expansion. And beta also having the unit for degree Celsius and SI unit for Kelvin for area. When it come to volume, for volume case we will get Vt minus V0 means increase in volume or final volume minus initial volume. Vt minus V0 equal to here more one constant or coefficient used, that is called gamma, means Vt minus V0 equal to gamma V0T, where gamma is the coefficient of cubical expansion or coefficient of volume expansion. Alpha for length, beta for area, gamma for volume. So if we come to the relationship between them, alpha is for length. So for area or coefficient of areal expansion, coefficient of superficial expansion, beta equal to 2 of alpha, and gamma, which is coefficient of volume expansion or coefficient of cubical expansion, gamma equal to 3 alpha. Means we got the ratio between alpha, beta and gamma as alpha is to beta is to gamma equal to 1 is to 2 is to 3. The relationship between all the coefficient means this coefficient depends upon the material, which type of material used. Means all the materials are having different coefficient. For degree rise in temperature, how much the length will increase, how much the area will increase, or volume will increase. It is the coefficient of linear expansion, coefficient of superficial expansion, and coefficient of cubical expansion or volume expansion. Now, uses of thermal expansion of solid means where we are using this all expansion. Sometimes expansion is advantageous, means having some advantage, helpful nature. Sometimes this expansion is harmful, you can say, or it is having some disadvantage. So let us start the first. First case, to fit the rim in a wheel of bullock cart or horse cart. To fit the rim, first thing we'll take the rim little bit smaller size in compared to the wheel. So when we'll give heat, this rim size will increase. Here the area will increase because it's a circle. Means superficial expansion. When the size will increase, easily it can go inside the wheel. Once it will go inside this wheel, then we'll heat so that it will remain tight, and we'll put some cold water. When cold water given to it, it will remain fully tight inside the wheel so that it will not come out from it. Next one, if we look. Next one, whenever we are taking the glassware in our kitchen, it is mainly made of Pyrex glass. Why it is made of Pyrex glass? Because Pyrex glass having coefficient of expansion very less. Means with the rise in temperature, its length, area or volume increase very less. For that reason, whatever the glass utensils we are using, glass vessels we are using in our kitchen, all are made of this Pyrex glass. So it will not expand more, it will not contract more. Third one, in a pendulum clock. In a pendulum clock, we are using one alloy of inbar. Inbar is the alloy. Inbar is the alloy of iron and nickel. Why we are using inbar? If we will not use inbar, if we use any other metal, then in summer days its length increase because of expansion, and in winter days its length decrease because of contraction. So to avoid that, we are using inbar. Inbar having very less, or you can say negligible coefficient of linear expansion, means its length will not increase or length will not decrease. Next one, if we look here, is the losing a glass topper by warming the neck of bottle. In some time, the glass topper will fix with the bottle. If it will try and will not come out, what you have to do is we will take the bottle and will take near the tap where it is coming warm water, or we can keep that neck of that bottle in warm water so that neck will absorb the heat. Once the neck will absorb that heat, its size will increase and easily the stopper can come out from that bottle. Next one, here you can see a small gap left between two successive rails. Means if we take a railway track, in that small piece of irons are attached with one another. So in that middle, we'll get certain amount of gap. This gap actually used to, or it will give the space for the thermal expansion. In summer days, when that length of rail will increase, so that that gap can be filled. If we will not give any gap, then because of expansion, that track will bend, which can make cause accident. For that reason, the small gap is left in two successive rail. More, if we will come to the next one, for the construction of a bridge. Here you can see one part of that bridge is fixed, other side it is having the ruler. Why they have given the ruler? This part means one side is free to expand, another side fixed. So because of friction, or because in the summer days when it can more amount of heat, expansion will take place, so the that bridge will not crack. For that reason, one side is free to expand. Next one, cracking of thick glass tumbler. Whenever we take a glass which is not made of Pyrex glass and will give hot water or hot liquid inside, inner part will expand and outer part will not able to expand because glass is a poor conductor of heat. So due to unusual expansion, glass crack. To avoid that, we are using the Pyrex glass, which is having negligible coefficient of linear expansion. Next one, in case of riveting. Riveting one you can see here. In case of riveting, two metal plates are attached to each other. Two plate will keep, and in that will make one hole, so that we'll take one nail. It can easily go inside. We'll hit to the nail so that its size increase and easily it can go inside, and we'll hit by the help of a hammer. So once you go inside, then we'll put water, we can keep ice so that it will cool down and will remain tight. So then two metal plate will not come out. Next one, fusing the platinum wire in the glass rod. This is called a platinum loop. In that platinum wire, the thin platinum wire is attached with a glass rod. Why we are taking glass rod? Because coefficient of linear expansion for platinum and glass is nearly same, and both are actually less, both are having actually less coefficient of expansion. For that reason, platinum wire we are using in glass rod. Next one, electric cable and telephone wires. During summer, its length increase, it expand. For that reason, we'll get that all the electric wires or telephone wire will loose. But in case when it will come to winter days, when the surrounding temperature is less, it contracts, means it will become tight. So we have to keep the electric cables or telephone wire like this, so that it will not loose more, it will not tight more. So these all are the example where we got that on heating a body increases length, increases area or volume, and when it will cool, its size decrease or contraction will get. Next one, when it come to the thermal expansion of liquid. In case of liquid, length, area will not able to increase, only the volume will increase, and every time liquid get inside the vessel, means whenever we are giving heat, the vessel will increase its size, as well as water or liquid also will increase its size. Means total amount of expansion, if you want to calculate, we have to take actual rise in the level of water plus the rise in the size of the vessel. Means when liquid expand in a vessel and will observe, it's not the actual increase in volume. That is the apparent increase. So that is the apparent expansion. Real expansion, which one? Real expansion is actually the real expansion means the expansion in liquid and expansion in the vessel. Both we have to calculate. Then only we will able to know what is the real or absolute expansion in case of a liquid. Means in case of liquid, we'll get the expansion in vessel also and expansion in its liquid level also. It's two expansion will get in case of liquid. Next one, whenever we are taking any liquid, sometime with the increase in temperature, its volume has to increase. With the decrease in temperature, volume has to decrease. But sometime volume with the increase in temperature, volume decrease. With the decrease in temperature, volume increase. That type of behavior is called anomalous expansion. Here, it is the anomalous expansion of water. Water is a commonly used liquid. In case of water, when temperature rise from 0 to 4 degrees, 0, 1, 2, 3, 4, with the rise in temperature, volume has to increase, but in case of water, volume decrease. And when reverse will take 4, 3, 2, 1, 0. Volume has to decrease, but in case of water, it will increase. That behavior, that abnormal behavior is called anomalous behavior. This is called the anomalous expansion. Anomalous expansion time 4 degree to 0 degree Celsius when temperature decrease, its volume increase. And when 0 to 4 degrees Celsius temperature increase, volume decrease. For that reason, at 4 degrees Celsius, water has minimum volume, maximum density because density equal to mass by volume. With the increase in volume, density decrease. With the decrease in volume, density increase. And anomalous expansion of water also helpful for aquatic plant so that they can remain inside when upper surface of the liquid freeze. Next one, when we come to expansion in gas. Gas molecules are having intermolecular space maximum. So when heat is given to it or when they will absorb the heat, more the space between them will increase, the kinetic energy increase more and volume increase more. Means they will occupy now more space. Because they will occupy more space, density decrease. Means this all about the expansion of solid, liquid and gas. Here we got different coefficient for linear expansion, superficial expansion, cubical expansion. All these three expansion possible for solid, but in case of liquid and gas, we'll get only the increase in volume or only will get the cubical expansion. This is all about your heat. Thanks for watching my video.